Hello everyone, welcome to my channel. In today's video, I'll demonstrate how to build serverless AI image generator using Amazon Bedrock. Amazon Bedrock is a fully managed service that provides access to various AI models like Amazon Titan, Claude, etc. etc. In this demo, we will see how to receive the prompt from the user and then pass it to the Amazon Bedrock to create the image and then store it in the S3 bucket and then return the URL, pre-signed URL to the user so that user can browse the image. Okay, let's get started. Before we proceed with our demo, let us explore Amazon Bedrock image creation from the console itself. I'm in the Amazon Bedrock web console. Under that, there is a section called test. Okay. Under the test, then we have option here, image video playground. We have the option here to choose the model. Select the model under the categories. I have selected Titan image generator G1 model. So this model will be used in our demo to generate the image. Okay. Selected, apply. Then let us explore the options. The action is generate image. And let us see the next option, negative prompt. If you want AI to avoid any mistakes, you can give some negative prompt. And then let's go down, response image, the size of the image, number of images. Let us keep one for this demo, one image, and color options and conditioning image. You can upload any references, and then there's an important thing, advanced configurations. The prompt strength is 8. How strictly the AI should follow your prompt? So the image strength is, the default setting is 8, so it is somehow balanced. And then the last one is seed. You can send any value, but the value, if the value is similar, then you will be getting the similar images. Okay. Now I'm going to paste the prompt in this box and going to run this one to see the image. Okay. Our image is being generated. Now we got the image, beautiful image, and there is option here to download the image. But if you go a little bit up, you will see there is another button here to click to view the API request. Let us understand the API request details. AWS Bedrock runtime invoke model API. Under that, you will see -- model ID that is pointed to Amazon Titan image generator, and then there is a body. Inside the body, you will find text to image params. It's a text. Our complete prompt have been added here, and then set of other configurations are added in this payload, especially task type, image generation config. Then under the image generation config, you will find a CFG scale, and then the seed and other height, width, and other parameters have been added as a part of this payload. Okay. So in our demo, we are going to initiate the similar API request. Okay. Let's quickly see the architecture of this demo. Let us create the user. Okay. Just a rough diagram of user. User will send post request. Okay. So this will be the post request. Post request. In the post request body, user will send the prompt. Okay. So user will send the prompt. This is the API gateway. User will submit the prompt by calling the API. Okay. So this API will target to a Lambda function. So this is the Lambda function. This Lambda function, then it will call Bedrock. Bedrock for image generation. Okay. So this prompt will be, this is the request. Okay. So the Lambda function will initiate request with the prompt. Okay. The complete request to call, it will send the request to Bedrock. Then the Bedrock will respond with the image. Okay. If we quickly update image, then the Lambda function will store the image to a S3 bucket. So this is S3 bucket. And then from the S3, again, this Lambda function will generate pre-signed URL. Okay, so this one is store image, and this one is retrieve create pre-signed URL. Okay, sending the pre-signed URL all the way back to the user. Okay, so user will see pre-signed URL of the image. Okay, so the user will initiate the request. User will submit the post request with the prompt, the API gateway, then it will send the request with the prompt to Lambda, call the Lambda function. Then Lambda function will talk to Bedrock to create the image and then retrieve the image and then store the image to S3 and create the pre-signed URL and then set the pre-signed URL all the way to the user. So that's the architecture of this demo. Let us explore the solution implementation. You can see the project. It's a NestJS application. Let us first explore the package.json to see the list of packages installed. If you see the dependencies, we have installed 3 important packages which are client Bedrock runtime to talk to the Bedrock, and client S3 to talk to S3, and S3 request pre-signer, okay, to generate the pre-signed URL. And one more package UUID to generate unique identifier to create a file name in S3. Okay, and there is some dev dependency, most importantly types of Lambda. Okay, and that is from the package.json. Now if you look into the source folder, inside the source folder you will see the app controller. The app controller have only one method, which is a post method, generate post method. Okay, so it accepts the prompt in the body, the post request. The prompt comes inside the body and pass the prompt into the GenAI service. Now let us explore the GenAI service file. This is a GenAI service. If you see, these packages have been referenced: Bedrock runtime, client S3, and pre-signed URL. Okay, for pre-signed URL, S3 request pre-signer. These objects have been created. The most importantly, generate image function. Okay, this function accepts the prompt and returns the promise. If you notice, first of all, we have to talk to the Bedrock, right? We need to generate the image. So for that, we create the payload. The payload is created, okay? And that payload contains all the configurations. You can see image generation configuration, CFG scale, seed, width and height of the image, and number of images. All those configurations are part of the payload. And we have to initiate the API request invoke model command. Okay, by specifying the model ID, content type, accept, and that body. Inside the body, we have to pass the payload as a buffer. Okay, you can see the model ID here, Amazon.Titan image generator. Okay, then we have to send the request to the bedrock.send the whole object. Then we receive the encoded response, so we decode it, and then if you go down you will find the image array. We get the image array, the first array, the first image we take it, but that is a base 64 formatted. From that we have to create the buffer from it. Okay, image buffer. Then that buffer must be saved in the S3 bucket. So we create the unique identifier here. Then we will send s3.send put object command. Using that API, we will save the image inside the bucket. Okay. When then the final part generate pre-signed URL. Then we initiate another API called get signed URL. Then by passing the bucket name and the file key and setting the expiration time, by that we get the signed URL. Get the signed URL and return to the user. Okay. I have built this API using the serverless framework. You will notice a serverless.yaml file in the root folder where you will find all the configurations. For Lambda, it is pointed to the Node.js runtime, and you will see the IAM permission. So the Lambda require IAM permission to talk to Bedrock. You will notice the Bedrock.invoke model to invoke model API, and also the put object and get object API access for the S3 buckets. Okay, the entire application, NestJS application, wrapped into the Lambda code. I will show you in a bit. Okay, and these are the resources which is specified in the S3 buckets. Okay, I have also used the serverless offline where I can test offline before deployment. Okay, to the cloud. Now let us explore the lambda.ts. This is the Lambda code. This entire NestJS application wrapped inside this Bootstrap server. Okay, you will notice using the AWS Serverless Express, created the server and proxy these objects. Now you will notice the entire app module is inserted into the Nest factory. Okay, and created as a server. Okay, create server. Yeah. Now let us run. Okay, in the terminal, I'm going to run npm run build. Okay, build is succeeded. Now let us deploy everything to the cloud. SLS deploy. So this command will help us to package and deploy everything into the cloud. So let us wait for the completion. You will see the deployment is completed and it provided the endpoint. Now let us copy the endpoint. Copied endpoint into the Postman utility. I changed the set to the post method, and I copied the prompt inside the body. Okay, in the raw format JSON. Now let us hit the send. It's asking the prompt required. We need to change the JSON. Okay, hit send. I got the response. I'm just copying the image URL and paste it in the browser. There I got nice image. Okay, now let us quickly log into the AWS console and browse those services that we created. I have logged into the AWS web console. First, I'm going to the API gateway. This is to see the created API. You will find the REST API image service. This one. So this is our API image service. Go to the Lambda. You will find image service. That's our code. Now let us finally check the S3 bucket where we store the image. This image bucket studio. Inside this image bucket studio, we have the image. Okay, these are the images. Other two images I created earlier. With that, I'm concluding this video. Thank you for watching. Bye.